In this video, we're going to work through a few problems that involve geometric series. Now, what a series is just the sum of a bunch of numbers. And we know the sum of a number is when we add together a bunch. So 1 plus 4 plus 16 plus 64. But if you're thinking, well, we have subtraction there too. Well, that's okay. Just think of 1 minus 4 is the same thing as 1 plus a negative 4. Now, what makes it geometric? Well, that means that we take each number, and to get the next one, it's multiplied by the same number. So as you can see, we have number 1, we multiply that by a negative 4, and that gives us negative 4. And then you take negative 4, multiply that by a negative 4, and that gives us positive 16. Take 16, multiply that by a negative 4, and you're going to get negative 64. So the common ratio is going to be negative 4. And if you're thinking, well, is there a better way to figure that out other than just looking at it? And yeah, what I normally do is I take a number, in this case let's start with negative 4, and I divide it by the previous number, which is 1. And that's negative 4 divided by 1, which is, of course, a negative 4. That's how you could get that ratio. And we know that it's going to be common, which means the ratio between negative 4 and 16 is the same thing, negative 4, because it's listed as a geometric series. Geometric just means that that ratio is common, which is equal as we can go. Okay, so now let's get the sum of this series. And as you can see, I already have a formula written out. We have s sub 10 equals all this stuff right here. So as I fill things in, I'll explain what they mean. Well, s sub 10, that should actually be, let me change this should be 9. That means that we have 9 terms in our series. So then I have s sub 9, and then a1, that just means our first number. So the first number in our series is going to be 1. And then we have 1 minus r. R is the common ratio, and we figured that out to be a negative 4. So we're subtracting that. And then n is going to be the number of terms in our series, which we already said was 9. Now we're going to divide by 1 minus r. So 1 minus that negative 4. And we got to just simplify from here. So I'm going to bring down 1, and I'm not even going to rewrite that just because 1 times anything is just whatever that is. We're going to have 1 inside the parentheses minus negative 4 to the 9th power. That's going to be negative 262,144 divided by 1 minus a negative 4 is going to be positive 5. I'm going to keep simplifying. So now we have 1 minus a negative 262,144. That's going to be a positive 262,145 divided by 5, which will give us our final answer. That's going to be 52,429. I'm going to bring this down here. So that's going to be s sub 9. So that means that our first 9 terms in this series is going to add together to be this number right here, 52,429. In this question we have a series and it's finite, meaning there's a certain number of terms in it. We have negative 5 and then negative 10, negative 20, negative 40, and then this dot 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 means there's a bunch of numbers between this 40 and then the 2,560. So I'm going to use my formula again, and I'm going to do s sub, well, we don't know what n is. We don't know how many terms are actually in this series, so I'm going to leave that as n for now. But our first number is going to be a negative 5. We could plug that in there. And then 1 minus our r, and that was our common ratio. So to figure out what that is, I'm going to take a negative 10, divide it by our previous number, which is negative 5. That's going to give us 2, so then our ratio is going to be 2. And we know that that's common because we're told that this is a geometric series, so it means that that ratio is equal. And that's raised to an n. Again, we don't know how many terms are in this series. Divided by 1 minus our common ratio, which was 2. So now we have a problem. We don't know what our n is, and we need to figure out what that is in order to get the sum. So now I'm going to bring in another formula, this one right here, where we have a sub n equals a sub 1 times r to the n minus 1 power. and this is going to help us out find n. So a sub n, that means it's our last term, or that's what it represents. So we're going to plug in a negative 2,560. A sub n is our first term in the series. Our r is the common ratio, which is 2, and then we have n minus 1 here. So we only have one variable right here, and we could solve for it. So the first thing that we're going to do is get rid of this multiplication of negative 5. So to undo that, we're going to divide it. That goes away, and I divide it from the left side as well. That leaves us with this equation. Now to be able to solve for n, we need to somehow get that down lower. Because as of now, we can't just get n, or get our equation equal to n when our n is in our exponent. So we're going to use the inverse of this exponential function. So as you can see, I have written right here the standard form of an exponential function. To use the inverse, we would just switch spots with the x and the y. And then to write that in terms of y, we're going to use the log scale right here. And the nice thing about the log scale is that our exponent then could become equal to our equation. So I'm going to switch from exponential form to log form. That means I got to start with writing log, and then my little base here was our big base. So the big base was 2, so that means our little base is going to be 2. And then the part that goes in parentheses is whatever our equation was set equal to. So this one was set equal to 512, so that goes in parentheses. And then our exponent, in this case was y, is what is on the other side of the equal sign. So our exponent, n minus 1, is put on our other side of the equal sign. And now we're in a position where we could solve for n, or get it by itself. Log base 2 of 512 is going to be 9, and that's equal to n minus 1. Now we just add 1 to both sides, and 10 is going to be what equals n. So now we know that there's 10 terms in our series, and I could plug that 10 into this into this n right here, and we could get the sum. So here it is rewritten including the 10, and I'm going to start to simplify. If we raise 2 to the 10th power, we're going to get 1024, and then 1 minus 2 is negative 1, of course. Negative 5 divided by negative 1 is a positive 5, so that's how we get that 5 right there. And then 1 minus 1024 is going to be a negative 1023. And then when we multiply these two together, we're going to get a negative 5,115 is our final answer. In our last problem, we have a friend that deposits $400 into, let's say, an account to save for a vacation, and then she's going to add 10% more on each deposit. There's going to be a total of 12 deposits. So what we have here is a geometric series. And because we want to figure out how much she saved in total after 12 deposits, we're going to be adding those together. We want to use the formula that we used in our last problem. And here it is. So we have S sub n, and n represents how many terms are in this series. So there's 12 deposits, so we're going to do S sub 12. And then A1 is our first deposit, which was $400. And then we've got 1 minus the common ratio. And because she's depositing 10% more in each successive deposit, we're not just adding in 10%. We want to add in 10% including that 400. So what I mean by that is 400 was, of course, her first deposit, right? Well, then her second deposit is going to be 10% of that. So that's going to be a total of 440. So that goes in the second deposit. And then her third deposit would be 110% of this number. That's going to be 484, and so on. So we don't want to just put down for our R value 0.10. That would be 10%. We want to put down 1.10 because we want to include that previous term too. It's like we almost want 110%. So that's going to get plugged in right there, and then the n is 12 because we have 12 deposits, divided by 1 minus our r, which was 1.10. And at this point, we just got to simplify everything. So I'll write down 400 times 1 minus 3.138, and the 3.138 is just rounded from 1.10 to the 12th power. Simplifying a little bit more gives us a negative 2.138 in parentheses, and then I'm going to multiply that by 400. That gives us a negative $855.20. We want to divide that by a negative divide it by a negative 0.1. That gives us 8,552, and that means that we're going to have $8,552 in the bank account after she's